So this is the loading frame that we are testing a 2 meter span of beam. So this is the structural testing setup. The purpose of this loading frame is structural testing to evaluate the behavior of beams under various loads. So this is the 2 meter span of structural testing setup under loading frame, and also the materials. Here this is the control panel that we are going to originate the new file name on which we are going to testing the beam of 2 meter span and giving the file name. So first we need to give the file name. So here the material properties, we are going to determine the mechanical properties of the beam of 2 meter span.
Okay.
So the components includes beam, a horizontal structure with 2 meter span, and a loading frame, a rigid frame that applies loads to the beam. And also here we are going to apply the loads with the help of hydraulic jacks. And here we are setting the zero reading for deflection and load as 0 before going to start the loading control panel of the loading frame, before going to apply the load. And here the applications that we are going to obtain from loading frame is research to study beam behavior under various loads, and also for quality control to test the strength and durability of beams, and also for design validation to validate design assumptions and calculations. The testing parameters, which will include load capacity, that is the beam maximum load that the beam can withstand, and also the deflection, the beam's deformation under load, and also the failure pattern, that is failure mode in which the beam fails under excessive load. So here we are going to calculate the load versus deflection, and also the maximum load that the beam 2 meter beam can carry. So here we are going to apply types of loadings, that is static loading and dynamic loading. The static loading is applied to the beam. Dynamic loading means it is the varying load applied to the beam simulating real world conditions. So the testing configurations, which will include simply supported beam. The beam is supported at both ends and loaded in the middle. And also the fixed beam, the beam is fixed at both ends and loaded. And also the cantilever beam, one end of the beam is fixed, other end is loaded. So the measurement parameters, which will include deflection, strain, load displacement curve. So deflection means the beam's deformation under load. The strain, that is nothing but the beam's deformation per unit length. And load displacement curve, a graphical representation of the beam's behavior under load. And here the applications of these beams with the help of loading frame testing setup: structural engineering to design and test beams for buildings, bridges and other structures; for material science to study the properties of materials under various loads; and quality control to ensure that beams meet design and specifications and standard. So with the help of this, we are going to calculate the load versus deflection by using line graph, bar graph, scatter plot and histogram. And here graph components will be x-axis, that will represent the independent variable, y-axis that will represent dependent variable. And here the trends, graph interpretation is going to be done to trends, that is to identify patterns of trends in the data, and correlations determine the relation between variables, and outliers identify data points that deviate significantly from the norms. So here with the help of these graphs, the applications that will help data analysis, graphs help to visualize and understand complex data. The graph representation and failure analysis are crucial in understanding the behavior of materials and structures. That is, crack representation will be in terms of visual inspection, non-destructive testing, finite element analysis. The importance will be structural integrity, material selection and design optimization. Applications will be aerospace engineering, civil engineering and material science.